we're going to explore the stateless library for building state machines. So I'm going to implement this simple state machine, which has a model of a turnstile with the two states locked or unlocked. And you can unlock the turnstile by putting a coin in it, or cause it to be locked again by pushing its arm. So in my project, I've added the stateless library. I'm going to implement a basic example. I'm going to define my states, so the states of the arm of the turnstile, the locked state and the unlocked state, and then the enumeration of the triggers. I'm going to call them turnstile trigger. So the actions I have is push and insert a coin. I'm going to define my state machine. Say new state machine. Then I need to pass the list, the enum of states as a type, and then the actions that are applicable to the state machine. It's going to define the matrix of possible transitions between states. And I have to define then the initial state. So I'm going to say the initial state is going to be locked. Let's import the stateless namespace. So this is now my state machine. Now I can configure which transitions are possible. So I'm going to configure for the different state, the possibilities. So let's start with the locked state. I'm going to say I permit it via the push action to transition. Sorry, I'm going to start with the unlocked state. By the push action, I can transition to the locked state, and then the same for the lock action. So by inserting a coin, I can transition to the locked state. And let's try out how it works. So let's print out the state. And let's try to, okay, so the state is indeed locked, and then let's try to fire some trigger in the, so cause a state transition. So it's initially locked, so I'm going to insert a coin, and this should cause the state machine to unlock itself. Indeed, it is unlocked now. So what if you try to cause a transition that is not allowed? So once it's unlocked, I'm going to insert the coin again. So by default, invalid operations or not valid transitions are cause an exception to be fired, but you can configure it otherwise. So for that behavior, I'm going to say, for example, that if the arm is locked and you push it, you can just say ignore the fact of pushing it again. Or another option is to say, for example, if you insert, if it's unlocked and you insert a coin, you have a re-entry into the state, right? So both will cause the state to remain what it was, but if you say permit re-entry, you can add, of course, hooks and actions when you enter and leave a state. So re-entry is really leaving the state and entering it again. So these actions would be fired, while ignore would just cause the action to be ignored, and you will just remain in the state without exiting and re-entering it. Now this is not failing anymore. We can output our diagram as a graph.viz file. So let's copy this into a sample graph.viz render online. And here we see our state. Indeed, we have these actions defined. Usually you will want to encapsulate the state machine as the internal state and driver for a given class that has the state, right? So I'm going to define my state, my class turnstile. I'm going to put the state machine inside, and then I'm going to define actions for it. So let's say void insert a coin. So now I'll put my insert coin action in there, and then I'll have an action for saying push. I can define a string method to look at the state. Alright, I'm going to return turnstile. And I'm going to put here the state, and then I'm going to ask some machine state. To make this return a string, of course. This will make proper field of class. How do we keep read only? Let's configure a machine in the constructor. Again, it's locked initially, so I'm going to say to make this method public. I'm going to say insert coin, write it out again. Indeed, it works as expected. Now let's say I want to be able to serialize this object to JSON. So say turnstile as JSON. So JSON convert from the JSON.NET library. So it's important. And then let's check what it is going to be. So I see the representation is empty because I don't have any properties defined here. So let's define one. And let's make it the state of the state right of the. Define the state of the turnstile as to be the state of the machine, the state machine. So now my states gets serialized. Let's check if we can properly deserialize that. Two. These are nice. Down style. So it didn't get deserialized as expected. That's because I need to properly, the deserialization is going to call this constructor, right? So I want to define a constructor for JSON deserialization that takes as input my state, right? String as a string. I'm going to have pass the statement to the state type, and then here state constructor state. Now indeed my object has been deserialized correctly, and we're serialized and deserialized as expected, and after serialization and deserialization I get the expected object back. So now let's check how we can use the state machine to actually drive some behavior. So I'll want, for example, to create a new field here that's going to be, let's say I want to create a green light that I'm going to put on the turnstile. So I want it when the turnstile is unlocked to have a green light turned on, so that the customer knows they can actually get in and push the turnstile. So I want to say whenever I have a change of state, I want to actually drive an action, right? So I want to say when I enter the unlocked state, then I want to cause an action, so an entry. I want to say when I enter the state, I want to say green light is true. And when I enter the other state, the locked state, I want to change it to false. Let's add this to my toString method. So I see indeed when I go from the locked to the unlocked state, my action is triggered. But then I see a side effect, right? When I do deserialization and reserialization, I see actually my action is not triggered. Why is that? Because I haven't actually entered the unlocked state, right? I just instantiated the state machine in that unlocked state right away. So how can I fix that? One way is to use activation instead of entry, right? I'm going to say when my unlocked state is activated, I want to drive this. And then when I deserialize my object, I'm going to call the activate method. So I'll encapsulate this serialization and deserialization into methods. To say public string to JSON. Do this and take down style from JSON. So here I'm going to say town style dot machine dot activate before I return. Let's use these methods. And I forgot to actually activate it in the first place. So when I fire an event, I want to say activate, right, to make sure my machine and my state is actually runs the activation actions. Now, indeed, when it changes state, it causes the activation to be called, but also when I deserialize my object, it causes the activation to fire as well. So now what if I want to unlock the town style only if the coin is of a sufficient value to actually open my town style, right? So for that, I'm going to want to be able to say, when I say insert coin, I want to put a value here, right? So for example, 10-cent coin. I'm going to say 8 cents. Then I want to be able to fire here, passing the value. So I want to actually change this standard trigger into a parameterized trigger that can take as an argument the value. For that, I'm going to create a parameterized trigger. Say coin inserted. I'm going to say set trigger parameters. I want a single integer parameter. I'm going to associate this with a given action. Make this field one. I'm going to say coin inserted, pass the value. So for now, I'm not using this value for anything, but it's checking I'm passing it correctly. So to actually drive my transitions based on the values of the trigger, I'm going to use a variant of the syntax, which is going to be permit if. I'm going to say with my coin inserted action, and say I go ahead into this state.unlocked, but only if the value is sufficient. Right? I'm going to say sufficient value. Take the trigger parameter. To say, for example, it has to be at least 10 cents. So here it succeeded. If I then change this value to insufficient value, then it's going to fail because there is no transition allowed. For example, I want to say actually allow to ignore in that case, right? So for example, ignore it or inserted, and then if it's not sufficient value, right? So that makes sense. So now it has remained in the locked state throughout.